The ancient Greeks lived in a world full of mysteries. They looked up at the stars and wondered about the cosmos. They observed nature and tried to understand its secrets. One of these secrets was the strange property of amber, a fossilized tree resin that held a captivating allure for the Greeks. Amber was more than just a beautiful gemstone. It possessed an unexplained ability to attract light objects when rubbed with cloth, a phenomenon that intrigued the curious minds of Greek philosophers. This simple observation sparked a chain of investigations that would ultimately lead to the discovery of one of the fundamental forces of nature, electricity. Amber was highly valued in ancient Greece. It was used in jewelry, ornaments, and even as a key ingredient in perfumes. The Greeks called amber electron, a name that would later give rise to the term electricity. They believed that amber possessed magical properties, and its ability to attract small objects only added to its mystique. Little did they know, this magic was the first clue to a hidden world of electrical charges, a world that would take centuries to fully unravel. The Greeks' fascination with amber demonstrates their thirst for knowledge and their keen observation of the natural world. Their inquiries into the properties of amber were not merely philosophical musings. They represented the first steps towards a scientific understanding of electricity. The stage was set for a breakthrough, and it would come from a philosopher named Thales of Miletus, a man who dared to question the magic of amber and sought a rational explanation for its curious behavior. Thales of Miletus, often hailed as the father of science, lived in the 6th century BC. He was a philosopher, mathematician, and astronomer, and is credited with being the first to predict a solar eclipse. But perhaps his most enduring contribution was his investigation into the strange properties of amber. Thales observed that when amber was rubbed with wool or fur, it acquired the ability to attract lightweight objects like feathers and dust. Unlike his contemporaries who attributed this phenomenon to supernatural forces, Thales sought a natural explanation. He proposed that the act of rubbing amber transferred something invisible to it, something he called a charge. This charge, he theorized, was responsible for the attractive force exerted by the amber. Thales's idea was revolutionary. It was a departure from the prevailing mystical explanations and represented the first attempt to explain the phenomenon in terms of a physical property. This marked the beginning of the scientific study of electricity, a journey that would span millennia and lead to profound insights into the workings of the universe. While Thales's theory of charge was a groundbreaking insight, he couldn't fully explain the nature of this charge or how it was generated. It would take centuries of further investigation and experimentation to unravel the complete story of electrical charges. But Thales's observation planted the seed of curiosity, inspiring future generations of scientists to delve deeper into the mystery of amber and its invisible force. Centuries after Thales of Miletus, scientists discovered that the charge he theorized about was not a singular entity, but came in two distinct forms, positive and negative. These charges, much like the poles of a magnet, exhibit specific behaviors when they encounter one another. Like charges, two positives or two negatives repel each other, pushing away with an invisible force. Conversely, opposite charges, a positive and a negative, attract each other, pulling together as if drawn by an invisible bond. This fundamental principle of attraction and repulsion governs the interactions of charges in all electrical phenomena. It's the driving force behind the spark that jumps between your finger and a doorknob on a dry winter day. It's the reason your hair stands on end when you rub a balloon on your head. And it's the foundation for the operation of countless electronic devices we rely on every day. The discovery of positive and negative charges provided a more complete picture of the electrical world. It explained why amber attracted some objects but not others, and why sometimes objects repelled each other after being rubbed. This understanding paved the way for further investigations into the nature of charges and how they could be manipulated to create and control electrical currents. Imagine a beach covered in countless grains of sand. You can't have half a grain or a quarter of a grain. Sand exists in discrete, indivisible units. Similarly, electrical charge is not a continuous fluid, but is quantized, meaning it exists in distinct packets. Each of these packets carries a specific amount of charge, and this amount is incredibly tiny, far smaller than the smallest grain of sand. The smallest unit of charge is associated with fundamental particles like electrons and protons. Electrons carry a negative charge, while protons carry a positive charge. These charges are equal in magnitude, but opposite in sign, ensuring that atoms which contain equal numbers of protons and electrons are electrically neutral. The quantization of charge is a crucial concept in understanding the behavior of electricity. It explains why charge can be transferred from one object to another in discrete amounts, like transferring grains of sand from one bucket to another. It also underlies the operation of electronic devices, where the flow of charge is carefully controlled to perform specific tasks. From the simple observation of amber attracting dust to the intricate workings of modern electronics, our understanding of electricity has come a long way. The ancient Greeks' fascination with amber ignited a spark of curiosity that led to centuries of scientific inquiry. Their insights into the nature of charges, their interactions, and their quantized nature laid the foundation for the electrical revolution that transformed our world. Today, electricity is an indispensable part of our lives. We use it to power our homes, communicate across vast distances, and explore the universe. The journey from ancient amber to modern electronics is a testament to the power of human curiosity and the enduring legacy of scientific discovery. It shows how even the simplest observations can lead to profound insights that shape our understanding of the universe and drive technological innovation.